The units digit question. This is a very frequent question type on the test. Almost every quant section will have at least one of these. And it looks really hard. People who are not familiar with this question type, they see it, they panic because it looks impossibly difficult, but it's actually very easy. So for example, a typical question of this sort, what is the units digit of 57 to the power of 123? Now your first impulse might be, oh my, I need a calculator to figure out what 57 to the power of 123 is. Well, I'll share with you something. This is not something you'd be able to figure out on your own necessarily, but I'll share. As it happens, this number is 216 digits long. So in other words, no calculator in the world is going to be able to figure out 57 to the power of 123 for you. It turns out there are web applications. For example, if you're familiar with Wolfram Alpha, that's something where you could go, you could enter this, you could actually see all 216 digits if you were really fascinated with that sort of thing. But the point is, no calculator is going to help you with this. Now, at this point, this probably really blows your mind. Why is the test asking you to do something that no calculator on the planet can do? Well, let's be careful here. No calculator on the planet could figure out that entire power, all 216 digits, but we don't need all 216 digits. We only need the units digit. And it turns out that is a remarkably easy question. So first of all, I'll point out the general strategy that we're going to use. We're just going to look for a repeating pattern, and then we're going to figure out where that pattern will be at the desired power. So I'll have to explain this in more detail, but first of all, we need a really big mathematical idea. Here's the big mathematical idea. The units digit of any product will be influenced only by the unit digits of the two factors. Therefore, we only need to consider single-digit products when tackling a unit digit question. Now, this is a profound idea, and it takes some time to sink in. Let's think about this for a second. 3 times 6, we know, is 18. So if we multiply a unit digit of a 3 times a unit digit of 6, I get a unit digit of an 8. That means any long number ending in 3 times any long number ending in 6 will be a long number ending in 8. In other words, all that matters is the unit digits. The unit digits of the two factors is the only thing that determines the unit digit of the product. Now, if this is a hard idea to understand, what I strongly suggest is stop this video, pick up a calculator, and actually try this for yourself. Enter some numbers. Say, enter a number in the hundreds. That has a unit digit of 3. Enter another number in the hundreds. That has a unit digit of 6. Multiply them together. Time and time again, you will get some bigger number with a unit digit of 8. You'll always get that same unit digit in the answer. Then try some other combinations of digits. Unit digit of 2, unit digit of 7, or unit digit of 3, unit digit of 9, something like that. Just pick your own combinations. Do the single digit multiplication. So 3 times 9, for example, is 27. So unit digit of 3 times a unit digit of 9 will always have a unit digit of 7. Again, experiment with this and verify for yourself on your calculator that it works. If you're not a mathy sort of person, one way that you build intuition for numbers is actually playing with numbers and seeing these patterns. That's why it's very important actually to pick up a calculator and verify for yourself that this pattern works. This is the pattern we're going to employ. So first of all, our big granddad question here, 57 to the power of 123. Well, first of all, the tens digit doesn't matter at all. So I might as well just consider powers of 7. Because any number that ends in 7, when I take powers of it, it's going to have the same unit digit as just the powers of 7. Only the unit digit matters. So 7 to the first, of course, just 7. 7 squared, 49. I'm just going to write that as something 9. We have a unit digit of 9. 9, and then multiply by 7 again. 9 times 7, 63. So now we have something with a unit digit of 3. 3 times 7, 21. That's a unit digit of 1, so now we have a unit digit of 1. 1 times 7, we have a unit digit of 7. 7 times 7, 49, we have a unit digit of 9. 9 times 7, we have 63, we have a unit digit of 3. 3 times 7, 21, we have a unit digit of 1. And notice what results here is a repeating pattern. It's like mathematical wallpaper. We get 7931, 7931, 7931. It's just going to go on like that forever. It's a repeating pattern. The period of the pattern. The period of the pattern, how many steps does it take to repeat? Well, it repeats in a batch of 4. Every 4, it repeats. Now that's very important. It's very important to figure out the period of the pattern. Almost all these unit digit questions, incidentally, the period will be 4. If it happens that we're doing powers of 9, that has a period of 2. That makes things a little bit simpler. But if it's a period of 4, this is most typical for most of the unit digit questions you'll see on the test, the period will be 4. What that means is every time we get to a multiple of 4, when the power is a multiple of 4, we always come back to the same place. So 7 to the 4th has a unit digit of 1. 7 to the 8th has a unit digit of 1. 7 to the 12th, the 16th, the 20th, the 40th, the 80th, all of those would have unit digits of 1. That tells us how to extend the pattern, because 120 is a multiple of 4. So that means 120 will have a unit digit of 1, just like all the other multiples of 4. And then we just continue the pattern from there. After 1, we have a unit digit of 7. After 7, we have a unit digit of 9. After 9, we have a unit digit of 3. So that means 7 to the power of 123 has a unit digit of 3. And therefore, any number ending in 7 to the power of 123 would have a unit digit of 3. So that means that our friend here, 57 to the power of 123, has a unit digit of 3. And that's the answer. Notice that we had to do absolutely nothing beyond single-digit multiplication to answer this question. This question is always designed as a non-calculator mental math question. That's very important to appreciate. So the strategy for the unit digit question, focus only on single-digit multiplication. Look for the repeating pattern and determine the period. And again, most often the period is 4. And then extend the pattern using multiples of the period. This is the technique we use to solve these questions.